Assalamualaikum warahmatullahi wabarakatuh. Good day, ladies and gentlemen. First, I say thanks to Organization Committee of International Conference on Mechanical, Electronics, Computer and Industrial Technology. Here, I will present my research about population initialization in genetic algorithm for traveling salesman problem using steepest ascent hill climbing algorithm. I'm Paet Rahmadani and my friends Muhammad Jaris and Sharil Effendi are author in this research. Introduction. Solving optimization problems using genetic algorithm is quite difficult because the quality of decisions that are solved using genetic algorithm is related to many characteristics such as initial population, crossover, mutation, probability, fitness function, selection factors, and other factors. All of these factors influence one another as a system. The steepest ascent hill climbing algorithm is basically almost the same as the steepest ascent hill climbing algorithm. The difference is that the search movement doesn't start from the leftmost position, but the next movement is took based on the best heuristic value. Genetic algorithm is an artificial intelligence algorithm used to find optimal solution for computational problems in order to maximize or minimize certain function, while the steepest ascent hill climbing is also an algorithm for artificial intelligence, which is the development of simple hill climbing algorithm. The difference is simple hill climbing determines the next situation by comparing the current state with the previous situation, and the better situation is chosen as the next section, while steepest ascent will compare the current situation with all existing successors so that at steepest ascent hill climbing, the next statue is the best or closest successor to the goal. In simple hill climbing, the primary nearer node to the solution is chosen, while within the steepest ascent hill climbing, all successors are in comparison and the closest node to the answer is chosen. Simple hill climbing is more efficient than the steepest ascent hill climbing, especially in domains with an excessive branching component, the use of high price assessment characteristic. Therefore, it is preferred to use a simple hill climbing in the planning domains. The problem-solving process is broadly solved in two main stages, namely simple hill climbing and genetic algorithm. Simple hill climbing is applied to determination of initial condition or initial state. The following conditions arise from the initial state are successor, and the final condition or goal state. Genetic algorithms are applied for advanced processes, namely reproduction, crossover, mutation, selection, and evaluation. This makes the reason to examine the application of the steepest ascent hill climbing algorithm is an alternative method in order to generate good initial population for genetic algorithm. Proposed method. Genetic algorithm is a search technique based on natural selection and genetic mechanism. Genetic algorithm different from conventional search techniques, where the genetic algorithm conditions begin with the initial setting of a random solution called the population. Every individual in the population is called a chromosome, which represents a solution to a problem. A chromosome is a simple string of binary bits. Chromosomes evolve through continuous iterations, called generations. In each generation, chromosomes are evaluated based on an evaluation functions. The steepest ascent hill climbing method is one of the many methods of artificial intelligence to solve optimization problems. Because the algorithm is quite simple, the steepest ascent hill climbing method has been widely applied in various applications. The steepest ascent hill climbing method is almost the same as the generate and the test method. It's just that the testing process is done using the heuristic function. The generation of next state is very dependent on the feedback of the testing procedure. Testing is in the form of a heuristic function will show how much the guess value is taken against other possible conditions. The steepest ascent hill climbing method is a variation of depth first search or DFS. With this method, exploration of decision is carried out by means of depth first search, namely by looking for steps or paths that aim to reduce costs to get to the decision or goal by always choosing the smallest heuristic value. Traveling salesman problem is an optimization problem that can be applied to various activities, such as routing. The problem of TSP optimization is well known and has become the standard for trying computational algorithms. The main problem of the TSP is that a salesman must visit a number of cities that are known to be a distance from one another and return to their hometown. Result and discussion. The steepest ascent hill climbing algorithm is an optimal local algorithm is applied to improve the performance of genetic algorithm in order to avoid genetic algorithm in the problem of premature convergence so that optimal solutions are achieved in the solving the traveling salesman problem or TSP problem. This study analyzed the application of the steepest ascent hill climbing algorithm in determining population initial for genetic algorithm. A good population initial is expected to help genetic algorithm in finding the shortest distance solution in the case of TSP. In the application, the steepest ascent hill climbing or GA method is the generation of individual initial on the GA with the steepest ascent hill climbing algorithm. With this method, the best value is 2,667. The results are obtained by applying the number of individuals 100, the number of iterations 100, the mutation probability 0.10, and the crossover probability 0.75. In conclusion, the number of individuals is very influential in determining the total distance. The greater population applied, the solution obtained be better. In the study, the authors applied the steepest ascent hill climbing GA method, namely the initial generation of individuals on GA with the steepest ascent hill climbing algorithm. With this method, the best value is 2,667. The results are obtained by applying the number of individuals 100, the number of iterations 100, the mutation probability 0.10, and the crossover probability 0.75. Thank you. Assalamualaikum warahmatullahi wabarakatuh.